Jupiter, our solar system's largest planet, holds secrets beneath its swirling clouds that have puzzled scientists for centuries. From diamond rain to massive storms, we'll explore the mysteries of this gas giant's turbulent atmosphere and hidden depths. Let's talk about Jupiter's most famous feature, the Great Red Spot. This massive storm has been raging for at least 400 years since we first spotted it through telescopes in the 1600s. To give you an idea of its size, you could fit 3 Earths inside it. This giant storm spins faster than any hurricane we've seen on Earth, with winds reaching speeds of up to 400 miles per hour. The fascinating thing about the Great Red Spot is that it's actually shrinking. Scientists have noticed it getting smaller over the past few decades, though it's still massive enough to dwarf our entire planet. The spot's reddish color comes from chemicals in Jupiter's atmosphere, possibly from simple compounds containing phosphorus or sulfur, though scientists are still debating the exact cause. Beyond Jupiter's colorful cloud bands lies something unexpected, a deep blue core. Scientists using powerful telescopes and data from space missions have found that Jupiter's center isn't what we once thought. As we go deeper into the planet, the intense pressure turns hydrogen gas into a strange metal-like liquid that conducts electricity like copper wire. This creates Jupiter's powerful magnetic field, which is 14 times stronger than Earth's. The pressure at Jupiter's core is mind-boggling, about 650 million times what we feel at Earth's surface. Think of squeezing the weight of 650 million atmospheres into one spot. This core might be as hot as the surface of the Sun, reaching temperatures of 35,000 degrees. Those beautiful stripes we see on Jupiter aren't just for show, they're actually huge wind patterns moving in opposite directions. The light-colored bands are called zones, while the darker ones are belts, and they're always on the move. These bands form because of how Jupiter spins and how heat moves from its warm center to its cooler outer layers. Think of it like massive rivers of wind in Jupiter's atmosphere, some moving east and others west, creating those distinct stripes we see from Earth. These winds are incredibly powerful, reaching speeds of up to 335 miles per hour. The colors we see come from different chemicals in Jupiter's atmosphere. The white stripes contain ammonia clouds, while the darker bands show us deeper layers of the planet's atmosphere. This pattern of alternating bands helps Jupiter move heat around its surface, similar to how Earth's ocean currents work, but on a much bigger scale. Jupiter's lightning storms make Earth's thunderstorms look like tiny sparklers. These massive bolts flash with 3 times more power than anything we see on Earth, lighting up areas as big as entire continents. When the Voyager spacecraft first spotted these flashes in 1979, scientists could hardly believe their eyes. Jupiter's lightning mostly appears near the planet's poles, glowing bright blue against the dark clouds. The really cool part: these storms help create new chemicals in Jupiter's atmosphere, including some that give the planet its unique colors. Each flash releases enough energy to power an average American home for several years. And unlike Earth's lightning, which usually strikes from cloud to ground, Jupiter's lightning happens entirely within its thick layers of clouds, creating spectacular light shows that can be seen from space. Deep inside Jupiter, something amazing happens. Regular hydrogen turns into a weird, shiny liquid metal. This isn't like any metal we have on Earth. It only exists under extreme pressure, like what you'd find 13,000 miles below Jupiter's clouds. The pressure is so intense it squeezes hydrogen atoms until their electrons break free, making them act like a metal. This metallic hydrogen ocean is incredibly important. It's what powers Jupiter's super strong magnetic field and helps give the planet its unique properties. The temperature down there is a whopping 35,000 degrees, hotter than the Sun's surface. Scientists think this metallic hydrogen layer is about 25,000 miles thick, making it bigger than Earth's entire diameter. It's like having an ocean of liquid metal bigger than our whole planet. When it comes to light shows, Jupiter's auroras make Earth's northern lights look like a small flashlight. These massive ribbons of light are the brightest in our solar system, covering areas bigger than Earth itself. Jupiter's powerful magnetic field pulls in charged particles from space and its moon Io, creating constant auroras that never stop glowing. Unlike Earth's occasional green auroras, Jupiter's light up in brilliant blues, reds, and ultraviolet colors we can't even see with our eyes. The energy in these auroras is amazing. They're about 100 times brighter than Earth's and release enough power every few minutes to briefly power all of human civilization. Space telescopes like Hubble have captured stunning images of these giant light shows, helping us understand how Jupiter's magnetic field interacts with the solar wind. Jupiter's storms are fascinating, but they don't all last forever like the Great Red Spot. Scientists have watched several smaller storms appear and vanish over the years. In 2000, they spotted 3 white storms that merged into one bigger storm, nicknamed the Little Red Spot. But unlike its bigger cousin, this spot started shrinking and eventually disappeared. The key to a storm's survival seems to be its size and how it feeds on Jupiter's energy. Bigger storms can grab more energy from nearby winds and smaller storms, helping them stay alive longer. It's like a cosmic game of survival where the biggest storms eat the smaller ones to keep going. Recent observations show even the Great Red Spot is getting smaller, losing about 1,000 miles in width since the 1800s. But don't worry, scientists think it still has hundreds of years left to go. Here's something that sounds like science fiction, but is actually real. It rains diamonds on Jupiter. Deep in Jupiter's atmosphere, lightning storms turn methane gas into tiny bits of carbon soot. As these carbon pieces fall through the planet's thick atmosphere, the extreme pressure and heat squeeze them into diamonds. These space gems are probably about as big as a wedding ring diamond, and scientists think about 1,000 tons of diamonds form on Jupiter every year. The diamonds keep falling until they reach the superhot core, where they melt into a liquid carbon ocean. It's like having a jewelry store in the sky, except these diamonds would be impossible to collect. The pressure that creates them would crush any spacecraft we tried to send. Jupiter's magnetic field is like a giant protective bubble that's so strong it could power every city on Earth many times over. This magnetic shield extends up to 2 million miles into space. That's like stretching from Earth to the Moon 8 times. The field is created by fast-moving electrical currents in Jupiter's liquid metal core, spinning around as the planet rotates every 10 hours. This powerful field catches dangerous particles from the Sun and deep space, creating a safe zone around Jupiter. When these particles hit the magnetic field, they create those amazing auroras we talked about earlier. The field is so strong it even protects some of Jupiter's moons, though it can also blast them with radiation. Thanks to this magnetic force field, Jupiter acts like a cosmic vacuum cleaner, helping keep our solar system cleaner and safer. NASA's Juno spacecraft has completely changed how we see Jupiter's storms. Flying just 2,600 miles above the cloud tops, Juno showed us that Jupiter's storms are much deeper than we thought. Some reach 30 miles down into the atmosphere. The mission captured amazing 3D views of the storms, revealing they look like giant whirlpools of gas. Juno discovered that the Great Red Spot is actually 200 miles deep, tall enough to reach from the ground to where airplanes fly on Earth. The spacecraft's special cameras also found smaller storms at Jupiter's poles arranged in perfect geometric patterns. 8 storms around one center storm at the North Pole, and 5 storms around one at the South Pole. Thanks for joining our journey through Jupiter's incredible mysteries. We've only scratched the surface of this fascinating giant. If you enjoyed learning about space today, hit that like button, subscribe for more cosmic discoveries, and share with your fellow space enthusiasts.